how the machine learning is a multidisciplinary field. So as we have seen, machine learning is taught in computer science at all levels of education. So machine learning is one of the aspects of education of computer science, and it certainly involves the aspects of artificial intelligence. It involves the aspects of building the intelligent entities. So if we see, machine learning is one of the sub area under the artificial intelligence, as we try to classify it under the bigger bucket. So artificial intelligence can be the bigger bucket, and machine learning can be one of the elements of your artificial intelligence. So as we see machine learning as an interdisciplinary or multidisciplinary field, we need to be learning not only the aspects of artificial intelligence, but then the aspects of mathematics. So if you are trying to build your career in machine learning, you should be thorough with statistics, probabilities, the likes of operational research, the likes of linear algebra, the likes of numerical analysis, the likes of matrices, uh, uh, the likes of differentiation integration. So these are the important aspects where your machine learning have dependency on mathematics, because all your models are based on these. So you should be good at numerical solutions rather than the symbolic manipulations kind of thing. So machine learning also have the dependency on engineering field, as we call it. As we look into it, machine learning is certainly a very important aspects of the engineering, as we see this across. Also, machine learning have a dependency on information theory, how the data and the computer scientists work on that part. So machine learning is also having some kind of connections or dependency on the philosophical part, the control theory, the psychological part, the neurobiological part, business and management science, and then the overall economics for it. So that's how your machine learning is not a simple single field. It is a multidisciplinary field which is meant for ensuring and learning from the other fields and aspects. So as we call Stuart Russells and Peter Norvig, they say AI is relevant to any kind of intellectual task, and it is truly a universal field. Similarly, the likes of machine learning is a multidisciplinary field which is dependent on various other fields of evolution, and then it is truly a universal field for learning. So let's try to see how the machine learning is dependent on good quality of data and the overall algorithms. So for the machine learning data, we need to have the right quantity of data. So insufficient quantity of data at times can be problem for sure. So let's try to take an example. A child can recognize vegetables with a few prompts, then identify the variations almost effortlessly. So initially, when you try to teach a child what kind of vegetables are there, you need to prompt the child. But then once things become easier for him, then a child is able to carry out the identification of it effortlessly. So for similarly for the machine learning, you need to have the sufficient amount of data being fed to the machine learning algorithms so that they can try to classify and create the pattern, and based on that, at later point in time, they should be able to carry out the identification task effortlessly. So as we see, your ML needs lots of data, and not a few examples, but the likes of millions and millions of data record is required for them to learn and to evolve. So algorithms tend to perform better with the more data you have. So as we as we have already seen, Peter Norvig and everyone is mentioning that the more data is being fed to the machine learning algorithm, the better is the overall performance. So your machine learning algorithms tend to converge on the right answer with the enough data, provided they are fit for the purpose. The quality of data, so it's not only the quantity, but then the overall quality of data is equally important when you are trying to come up with a kind of machine learning algorithms, and how are we trying to address those things. So quality of data and the quantity of data is equally important. So those things will help your machine learning algorithms to converge on the right answers with the kind of which is fit for the purpose. The next important aspect is having the wrong data set being fed across. So the example for this can be teaching a child about the sponges and expect them to identify a face cloth. So when you try to teach a child some aspect, and when you give him you try to correlate him to a new aspect, there might be issues with it because the child has not been exposed to it. So similarly, if there are wrong data sets which is fed across the machine learning algorithm, it might not give you the right set of results. So your ML needs the data that is representative of the problem you are trying to make them learn about. So your machine learning algorithm have to be fed with that data sets where you are trying to solve any kind of problems. So your ML can suffer from the likes of biases if you provide them a sample data which is from the wrong group. So let's assume that you are a banking institute and you are trying to identify any kind of frauds in the insurance company or in the insurance sector. So if, as part of the banking and insurance organization, if you feed the data of a customer which is the banking records, and then you try to ask your machine learning algorithm to predict the fraud in the insurance, it might not be able to give the accurate results because the kind of inputs which you have fed into the algorithm was for the customer data for the banking, how the transactions for the person were handled or managed, or how the various records of the banking are being handled and managed by various customer from the perspective of that. So you need to feed in the right set of data, the right set of information. If the wrong data set is fed across, you might not be able to provide the right set of output for the problem statements being at hand. And again, the next important aspect which we see is a poor data set, right? So the example for this is teaching a child the wrong answers to timetable, right? So if you try to teach wrong answers to a child, it will result into demonstrating the wrong output, right? So it's a similar way. So your machine learning needs the data that doesn't contain any kind of errors, that doesn't contain any kind of randomness or noise or extreme. So whenever you try to put the kind of data, your overall quality of data have to be extremely carefully evaluated. So your data should be free of errors, your data should be free of outliers, your data should be free of randomness or any kind of noises or extreme, because these data can result into problems which will result into poor results being demonstrated by your machine learning algorithms. So your ML needs the data that doesn't contain any kind of irrelevant features. So the kind and quality of data matters the most as well when you are feeding it across to the machine learning algorithm. So, so this is the perfect example wherein your ML algorithm, uh, how the ML algorithm works out in case of overfitting. So in this example, we need a good algorithm that doesn't suffer from overfitting. So now what is an overfitting? So let's try to see the examples with how the overfitting works So well, let's try to see, let's assume that a child is knocked over by a small cat, and uh, it thinks that all the animals are clumsy. So when a child is encountered with a small cat, which is knocked down uh, with it, so child developing this kind of perception that all the animals are clumsy in nature. So similarly, in the same way, the overfitting works, right? So it works well on the training set, but it does not work well on the journal data. So in the case of overfitting, there are large errors which are there in the real data or the journal data set. So that's the classic case of your overfitting. So your good fit, as we are representing it through the straight line, but in the real case we can see the sinusoidal behavior, which depicts that there are large errors in the overall data. So your curved fitted by the machine learning algorithm is too erratic and oscillatory, so you cannot predict the outcome based on this machine learning algorithm. So your data points are captured by the ML solutions which is there, and we can see these data points are not lying, they are not fitting on a straight line as depicted. So the straight line gives you a good fit, the ideal fit for your machine learning algorithm, but then with the with the errors generated due to the overfitting, uh, your your data will have, or your data is having lots of noise which has to be removed, and this results into the large error when your machine learning algorithm is trying to predict any output. So all these elements of error and overfitting has to be removed across. So let's try to look into the aspects of overfitting in detail. So as we call the machine learning algorithm, we certainly need to have good algorithms that do not suffer from overfitting. And as we gave an example of how a child getting knocked over by a small cat, and a child get a kind of perception or thinking that all the animals are clumsy. So it happens when an algorithm is too complex, and when algorithm is too sophisticated, the elements of overfitting do exist and do plays. And it also reduces the overall complexity of algorithms which is being put up in place, and it also reduces the number of attributes in the training data. So we should be using more training data to ensure the elements of overfitting are removed when we are trying to work out to remove the errors of the overfitting. And we should work out to reduce the overall noise in the data. So we should work to ensure how are we going to remove the outliers that can result into any kind of distortion of the data or the output. So reduce the noises in the data, remove the outliers, so that your overall results become more streamlined. And then we should be providing the constraints to the model. So your model has to be constrained. Constrain the model, make the model more simpler, try to limit the amount of overfitting which is there as a part of the algorithm, or as a part of algorithm being too complex. So these are the ways and mechanism by which we should be ensuring the overfitting uh, 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 overfitting as an aspect is removed from the machine learning algorithm when it is encountering any kind of data. Now, let's try to look into the another aspect of machine learning algorithms which they suffer. The next problem which they encounter is of underfitting. So your machine learning algorithm at times suffer from underfitting as well. So we need good algorithms which should not be suffering from the underfitting. So the example for the underfitting as we can think of is a child is taught what food is then So you are teaching a child, or the child is taught what food is, then asked to pick up out a red apple from it. So you teach child that what are the different types of food, and then you ask the child to pick the specifics of the red apple from it. So it means your machine learning algorithm has built a model which is too simple. So in the case of underfitting, the models are too simple to be there, and the kind of data which is fed across might not be handled well by the machine learning algorithm. So in the overfitting, the machine learning algorithms are too complex, but then in underfitting your machine learning algorithms, they are built which is too simple in nature. So as we see, in case of underfitting as well, the machine learning idle behavior should be on the straight line, which is meant for all the data points to be lying and fitting on it. But then the data points are lying either below or above the straight line, which shows that your machine learning algorithms are either too simple to capture the data points, and data points are not captured exactly by the machine learning solution. So we need to alternatively think of the machine learning and algorithm which generates the better model for the data, and we should be okay to remove these erroneous uh, data points if there are any, so that it is fitting the straight line. So the first and foremost thing is try to look for the algorithm which is able to address the problem. So if there is too simple of an algorithm, let's try to look and revisit the algorithm so that it is able to address the problem of underfitting.